Oh, wow, there's a lot of people on here.
Yeah, there really is. And so far, I'm seeing they're almost coast to coast. Looks like a big chunker from Ontario, but oh, now it's officially coast to coast. We've got from BC all the way to the Atlantic provinces. We'll just get started in a minute, folks. We're just waiting for people to file in, and um, we'll get going in just a minute. All right, it looks like most people have joined us now. So thank you so much for answering the first poll. I'm going to end that and show the results. So it looks like most people are from Ontario, but right across the country, we have representation. And I'm going to launch one more poll before we get going here. So let us know. Thank you so much for letting us know where you're from. Now we want to know what it is that you do in your occupation. Oh, look at that. Pretty much almost every category is highlighted here. Oh, we've got more people still joining us, Andy.
Very good.
Yeah.
Oh, we've got a nice mix.
Yeah.
Yes, we better be careful what we say, Steph.
Well, you know what, valid point. Yeah, because I think we've got almost everybody, other than renovators. I don't see any renovators in the crowd. I'm gonna have to work on that as a someone who's worked in renovations for many, many years.
Yeah, no kidding.
All right, I'll go ahead and end that, share the results. So it looks like the most people on here are builder developers. We've got construction and trades, government at all three levels, and energy advisors, academia, and the engineers and architects and other. Yes, for those who work in a different career that wasn't outlined, just let us know in the chat, and we'll look at that in a little bit. So welcome everyone. My name is Stephanie Coleman and I work with Building Knowledge Canada. Today we are going to be talking about cracking the building code, and Andy's going to take care of that for us. I'm going to be working behind the scenes, and so any sort of questions that you have for Andy, please be sure to use the Q&A function that you see down at the bottom there. That really works best for answering questions. And then if you have any just general comments or if you're having any technical issues, put that in the chat and I'll be able to help you behind the scenes while Andy is presenting. So, and at the very end, when we close the session out, we have a little survey monkey that will pop up. And so we'd really love to get your feedback on the session at the end. So Andy, that's all I have.
Thanks, Stephanie. And just so you know, you heard Stephanie said, put questions in the chat. That means all the hard questions you ask her, all the easy ones you ask me. So I do want to bring everyone's attention to, we have Angela Bustamante, who is director of our technical and quality assurance here at Building Knowledge. Many of you know Angela, and she's going to join us today too. So you might find her popping in and out of the chat today, answering some questions. Okay, so let's get started. You've met Steph, you know, obviously there's myself doing the presentation today. Building Knowledge, we've been around now for a long time. The company started by Gord Cook, and we now work across all of Ontario. We work in a number of other provinces as well, and then we have some sister companies in the US. So what we're going to be talking today is about specifically the Ontario Building Code in respect to the SB-12, the supplementary standard for energy efficiency in homes. And in particular, we're going to be focusing on, if you want to get really techie, it's section 3.1.2 of the SB-12, which speaks to performance. And we're going to be introducing you to a concept today that we're using to work with our builders and clients called the Builder 360. And it's how can we help clients move along this path of continual improvement? And folks, it's really about using building science. And we'll talk why that's so important as to use building science as opposed to just simply putting notional energy targets up in the air and trying to do certain things because they get you more points. So our agenda today is going to look a little like this. We're going to talk about performance, why now more than ever. We're going to talk about the nuts and the bolts of the code and talk about what's up with this airtightness thing. And then we're going to talk about the path. We're going to give you how what we're finding working with our builders today and many of you, how we're approaching performance compliance, whether you're a large production of well over 1,000 to 2,000 a year, or whether you're just a custom builder, one a year or less. We work the full gamut, and why performance is becoming such a nice, flexible opportunity to use. And then we're going to look at specifically opportunities. We've actually got permission to share some of the performance packages that have been developed with some of our builder clients and some of their projects, and we're actually going to put some costing to it. You can't hold us accountable for costing, though. Talk about that in just a minute. We're going to talk about how it simplified construction details. We're going to talk about this building permit application process and a couple of things that can be helpful and how we approach that as well too, so that performance is easy, because the world is very complex, not just for builders, but it's a very complex code for examiners, for building inspectors, for designers. It's a very complex code. And what we strive to do is let's just make this as simple and easy as possible so that we can end up with well-built homes and we have great bottom lines. And then we're going to talk about your trade partners, your team, and your consumer. So I always have to have a little bit of a caveat sometimes in these sessions. So just real quick, a little bit of a disclaimer. Number one, any of the construction costs we share with you today are notional. So as happy or sad as you are to see some of these costs, you've got to go do your own homework. The costs you see today are not representational of any specific builder cost. Again, they're things we've gained from our experience, and we have also used the Natural Resources Canada Builder CBAT tool, cost benefit analysis tool, to do some of the costing, and that's a tool that we've often used with our builders. So you all know what it's like. We don't need to tell you how things are. We've got construction costs that has gone up exponentially. We've seen cost of somewhere in 10 to 15,000 or more per home, just simply based on your panel and your wood type things. We've seen that the codes are getting incredibly complex. Our building permit applications are complicated for everyone, and our consumer expectations are growing absolutely exponential. And that's, of course, thanks to all those great television shows on HGTV where perfect homes are built in 36.5 minutes minus commercial time by people in clean brown overalls and clean white shirts. So many of you would have remembered slides like this from 2016, 2017, and that was back in the day when it looked like the province notionally was going to be headed towards net zero, and there were these proposed changes. We all know that that is no longer the case. We know that for now, when it comes to the SB-12, there are no current changes tabled between 2019 and at least 2021. So you're good going into the next year when it comes to the SB-12. The thing you need to understand, though, is that the Ministry of Municipal Affairs and Housing has embarked on a harmonization exercise with the other provinces, and they are looking at this thing called the Tiered 2020 National Building Code, which for your part would be Part 9. A lot of work has to be done yet. There is nothing about this that is a done deal. We would encourage you, as particular as builders and industry folks, get a hold of the Ontario Home Builders Committee and get involved. It's one thing to sit back and let things happen, and then either we're happy or we complain about it later on. But the reality is you can get involved now and you can affect change for the better. So we know where this tier building code comes from. We know that it suggested that at some point we're going to have this national code that's going to lead towards net zero energy ready homes. One of the things we need to understand, and again, this uses context setting, is that this national tiered energy code is about energy. It's not about carbon, and it's energy source neutral. It's not about electrifying the grid. Notionally, what it speaks to is, when it comes to houses and buildings, about a 70% reduction at the end of the day versus the original 2015 NBC, or what I would say that would be about since the early days of the SB-12. One thing to understand is this National Tiered Energy Code is significantly different than the British Columbia STEP Code. There is no mandatory air tightness testing. There is, in fact, a prescriptive path, so you don't need to do energy modeling. if you don't want to. So again, be careful of the myths, be careful of the things you hear on the street or in the industry, get the real facts. What does the tiered energy code mean for you as a builder? Right now in Ontario, for instance, the tiered energy code in Ontario notionally is approximately around tier 2 already. Those of you that are doing Energy Star are somewhere around tier 3. And those of you that are involved with net zero ready, net zero homes, you would be up around the tier 5. A couple things just to set the target, because as we talk today, you're going to want to reflect on this to understand what you need to do to plan as a builder, because some of the things we're talking about today, you're not going to want to go out and do tomorrow. This is about a 1, 5, 10-year plan on how to move forward and why performance is really going to be the key to your future. A couple things about this tiered energy code. Again, air tightness is not mandatory. There are credits for small homes, so that's not denoted on this slide. There are 2 different metrics. One is a overall energy efficiency performance target, and the other is a envelope. So in other words, you can't just build a shell and put 20 acres of photovoltaics on the roof and call yourself good. The other thing too is there are 3 ways to meet this, or will be 3 ways to meet this. One is prescriptive, pick your points like Energy Star, Enter Guide for new homes. You can use that if you want, or you can use any third-party energy modeling software you want, as long as it complies with 936.5 of the National Building Code and is aligned with Canadian codes and reference standards. So there you go. So it's complicated. You've got choices, you've got alternatives, you've got options. Here's the problem. There are opportunities, but there's a lot of risks. And you have to be careful about what you choose in the name of energy efficiency, or you will end up with unintended consequences. We often say to our clients these days and others, if you are not ready, if you're not prepared to actually drain the rain on your envelope better than what you're doing today, in other words, flashing windows and doors, don't put a stitch of more insulation in your walls. From a building science perspective, the draining of the rain, the envelope comes first. Again, if you're not prepared to do air tightness, don't put more insulation in the wall, because again, you're limiting the thermal energy. There's a lot of building science things to be careful of there. Some of the reason I speak to this is just my background as a builder, and then growing up at an early age back in the 1970s when we had an oil embargo. And we had a crisis, and across Canada and in the US both, we had this drive to make homes efficient. And what happened was we had some of the single biggest envelope building failures that came out of that drive to insulate. We had the Canadian Housing Improvement Program. We put insulation in and it caused attic rain. So we pulled it out and put in an air barrier. We learned that again in the 1980s, great, you're airtight, but now you need mechanical ventilation. And then finally, we got that into the code in the 1990s, and we're still learning. So again, be very careful about making changes in the name of energy efficiency without understanding the implications of building science. So just notionally, use house as a system. It's a Canadian concept. It's been around for years. It's a very simple concept that one change in one element of the home is going to affect another for the better or for the worse. And again, be careful when we have programs and codes accelerating so quickly, unless we can use building science. The other thing too we do have to understand is that the energy versus carbon, the choices are very complex. Right now we're talking about energy, but folks, the long-term gain is the reduction in carbon. Chris Magwood, a good friend of ours, Chris is doing some phenomenal work at the Endeavor Center. Go look him up. He's doing a lot of studies right now. He's developing a carbon tool that he's helping others like ourselves learn how to use, so we can actually look at embedded carbon or embodied carbon on a home. A couple things to keep in mind. If you're not careful, you can take a passive home or a net zero energy home, stuff lots of insulation in with fancy mechanicals, but the reality is the home will have to operate for 400 years to offset the embodied energy that went into those materials. You know, it's like the old story like Chris tells, the organic cotton bag. It sounds great, you feel green. The problem is it needs to be used 20,000 times to be an improvement over a plastic single-use bag. So again, some of these things we do have to be careful of. And when we look at total global emissions, the embodied carbon almost matches the operational carbon. Now, that said, the building science still stays the same. At the end of the day, even when we move beyond energy into carbon, you're still going to find that things like air tightness are still incredibly impactful on lowering carbon. And you're also still going to need very careful about moisture control in walls and dew point, because you likely will be using more wood-based products or things like that. Okay, let's talk about the building code, the nuts and the bolts. We're going to talk about the SB-12 code sections, and we're going to talk about what is the intention of the code besides energy. Because remember, before there was energy in the building code, there are life safety standards. In other words, we cannot do things to homes that will harm the occupant or put them in a position of having health implications. So here's what we have in the SB-12. We have the 3.11, which is in fact the prescriptive part of the building code. We today are going to be talking about 3.12, which is the performance. And within performance, you have the programs. The only programs, just so you know, the only volunteer programs recognized under the Ontario Building Code are in fact Energy Star and R2000. And then you have the modeling protocol to do the reference modeling and some of the softwares that you can use, and we'll talk about that later on. So when the Ministry of Municipal Affairs and Housing, I borrowed this slide from a couple of years ago when they came out with the 2017 reg, and I thought it was very informative. They shared with the industry that there were three things they were trying to do with the SB-12: preserve and reinforce the envelope, encourage air tightness and blower door, and prepare the industry for movement towards net zero like housing. What I want to do is I want to focus on this one. Why? Why did the regulators, why is it important from a building science standpoint, from a health safety standpoint, that air tightness was starting to be encouraged under our SB-12? So I'm going to show you. I'm going to send you these slides, but I'd like you to read this. This is the explanation of why air barriers are in our building code. And here's the problem, folks. Today, when we talk about air tightness and blower doors, we all get all caught up in it's energy efficient and it lowers the energy, and it does. But that's not why we have air barriers in the building code. The reason we have air barriers in the building code is because air leakage, only second to rainwater, is the #1 destroyer of homes in Canada. A week and a half ago, I pulled a bunch of mushy wood out of a house that I had constructed almost 20 years ago. And a lot of it was due to poor air barriers. We see this happening in attics. We do forensics. We see attic rain, and it's because of poor air barriers, not lack of venting. And remember, the reason air barriers went into the codes in the early 1980s, late 1980s, was because we couldn't let moisture get into the envelope. Here's the description in your building code. Here's the reason why we have to have air barriers: to prevent excessive moisture condensation in such places during the heating season. This is what happens when you don't have good air barriers. Again, I don't think I need to preach to the choir. We all get it. And folks, we are seeing it happen in a rush to make highly insulated envelopes, but we're not tightening the building envelope down from air tightness. And remember, here's a 35-year-old slide. All of us have seen this. We know that vapor diffusion is something that we're really not that concerned about. The big one that wets walls is in fact air leakage. Now, here's what I call the forgotten part of the SB-12. Many people have forgotten that this was actually in the prescriptive section. And this was where the Ministry of Municipal Affairs and Housing said, you know what? We need to encourage air tightness. In fact, without doing performance or energy modeling, if you just simply air test the home and meet 2.5, you can start to degrade or pull down or optimize other elements of the home, because air tightness is more impactful and more helpful. You'll see there were things like this. Just by doing an air tightness and meeting 2.5, you could reduce furnace efficiency and you could reduce basement insulation. How useful is this? Well, go and ask any architect or designer how easy it is to design a thin, narrow townhome and to have to fit a stair next to a common wall and get R20 continuous between the stair hole and the wall, when you already are limited between the stair hole and the garage wall by limiting distance. That's a big deal. We've seen builders have to go in and put spray foam there just to get their R values, and that's a design flaw. So what difference does it make if we can actually lower the amount of insulation and it has limited to no impact on the amount of energy that's lost, but it allows the design to take place? Here's just some notional cost savings that our team put together with a builder. This is several years ago, who said, you know what, I know I can hit 2.5 air change. It's a walk in the park. They were a large production builder. It wasn't an issue. And these are the things that they were able to take out of their home, or were able to reduce and to uncomplicate or simplify the design. Again, this is in the prescriptive part of the building code, 3.11. It's actually identified on the EADS form for prescriptive. It simply needs to be acknowledged on the EADS form. You simply need a blower door test when it's done to be validated by a company like ours or a good registered energy advisor, and you're done. So let's get back to performance path now. There's prescriptive and then there's performance. Here were the differences in 2017 when it came out. Number one, all of a sudden we had to put drain water heat recovery into prescriptive. All of a sudden we had effective R values. All of a sudden we didn't have that many trade-offs anymore. Now it was only air tightness. With performance, there was some pretty significant things that got changed. One was we went to a gigajoule metric. No matter what the software was, we had to show an energy reduction based on a metric of energy, gigajoule. Not talking programs, just talking metric. The appendix of the new SB-12 started to inform us as to what are the base assumptions that the energy modeling professional has to use. And this is something you need to be aware of. Regardless of what software you use, you had to use some baseline assumptions. And the other thing too to keep in mind is that the only volunteer programs that were suggested in here were Energy Star R2000. Again, it didn't talk about LEED, it didn't talk about Greenbuilt, it didn't talk about any of these other programs. It was simply Energy Star and R2000. So to understand how this works, there are two different EADS forms. One is for prescriptive, the other is for performance. And these can be available from your building departments, but they are two different separate forms. And we're going to talk a little bit more later about how these forms are filled out. So when it comes to performance path, what we're really talking about is a better home for less cost. And at the end of the day, giving your client a home that works while you're able to optimize the affordability of the home. So here's your 3.11. Everyone likely likes to use the A1, and why is that? It's the only package that doesn't have continuous insulation in it. And one of the other things that throws these packages off is a lot of the material, a lot of the other items on here, the equipment that has to be higher efficiency, are often rentals. And so it changes the game and the way we put our packages together. But what we're talking about today is let's get away from prescriptive and let's move on to performance. So here's the process that we use and that a good energy advisor will use to get you on a performance package. Number one is there's always a discovery concept or conversation. We need to learn some things. Then we want to get into the field and see how your homes or buildings have tested in the past. We want to have some discussions. We need to do some modeling. We need to do some assessments. And then we come back with a plan. And really what it looks like is a little bit something like this. Getting to know you, doing some optimization, and at the end of the day, implementing some of these things. During the discovery phase, you need to outline what are your goals. Is it to save money? Because if that's what it is, then let's work towards it. Is it to meet a volunteer program? Let's understand what that means. Or is it to meet a regional program? Some municipalities have some tiers that are in place. Toronto Green Building Standard puts an incentive in place with their DCs that starts to encourage higher incentives or higher ranges. What does that mean for your homes? And again, other goals to look at. A lot of work can go in behind the scenes. This is when we take your plan, we take your product, we go away and we do all sorts of analysis depending on what your needs are. We use costing tools as well. Here, what you're looking at here is a picture of the cost building assessment tool that Natural Resources Canada has developed. And we're able to look at cost, general cost, for different equipment and different options on the home, structural and enclosure options, to come up with a notional cost that can then inform you as the builder as to the difference it can make to your budget. We also start to look at the difference some of these things will make with your mechanical design, and also facilitate ease of design on the drawings. At the end of the day, what it is it brings it all back to an implementation plan. And typically with these optimizations, you start with code and then you move to whatever it is, whatever level above code or just meeting code you want to be. And then we at Building Knowledge always like to show you, regardless of your goals, what it would mean to be Energy Star or net zero ready. You're going to get that from us all the time, just so you understand what potentially in the future your homes may need to look like. Okay, so let's dive into some costing details. A couple things to understand. Is A1 really cheaper? And the answer is no. In fact, it's not that much simpler than performance, and it isn't cheaper. And there's four main elements we're going to talk about today. One is multifamily. The other is mechanicals when it comes to combos. We're going to look at what the opportunity is with air tightness, and we're going to talk about windows. So in general, we have found on average with our clients that when it comes to performance, there is about $500 to $1,700 per home savings, depending on the geometry, depending on the product type. And that includes any fees associated with the modeling, if there's testing or whatever else. This is like money that's left on the table. And the beauty of it is it can be done. You can actually increase the performance while decreasing the cost. And it can be done either with testing, blower door testing, or without. One of the areas that we find this is incredibly beneficial is with the multifamily. It's this thing called the missing middle. This is about 70 to 75% of the market that we're seeing out there right now. So here's a really simple example of a typical attached townhome. And this was an analysis that was done. And in the townhome, we were able, without doing any changes, with no air testing at all, just a simple model, drain water was pulled out. The attic insulation was reduced. Remember, it was a small attic, and there's hardly, it makes a hill of beans difference, whether it's 50 or 60, even to the thermal comfort of the occupant, or over the next 50 to 60 years when that's what you have. Remember, to cut a heat loss in half in an attic, you actually have to double the R value. So when we're getting to R50, we're starting to bump up against the bottom edge of the law of diminishing returns. The geometry of the unit is also efficient. With multifamily, you have common walls, you have less exposure, you have fewer windows in some scenarios. And again, the geometry itself lends itself to a more efficient form. And this is nothing new. I remember architects talking about this in the 1970s and 80s. So to give you a closer up here, what happened was at the end of the day, we pulled down the attic insulation. They took that out. They took the drain water out, and including the modeling fees, again, and these are just notional, they just as a placeholder, but at the end of the day, it was a $750 reduction per unit cost on a site of 10 or more homes, and you can add that up as it expands. The other part I want to talk about is air tightness. It's not a matter of if, it's really a matter of when you're going to get to the point to consider air tightness. A number of builders, even production builders, have started to see the benefit of this. Some of Canada's largest, best performing builders do air tightness as a standard. They see it as a quality control measure. They also see that it gets them along the road with performance and saves money on the cost of the home meeting the energy code. And they like the results it delivers on the site. But again, it takes a special relationship with the evaluator to make this happen, but it absolutely can be done. Let's talk about air tightness. So here's the sample project that was done. And what this is showing is that in this case, again, we'll take a townhome, air tightness was done. So a blower door test was done. They achieved the level of air tightness. And in this case, it was a townhome. So it was 3 air change that was achieved, which is very achievable from a multifamily perspective. The attic insulation went down, drain water came down. They wanted to reduce the basement insulation, again, because of the stair hole implications, to give room for the design to happen. Also, the geometry lended itself, and again, all told, it was $1,000 per unit. Now, let's look beyond the savings and look at the total effect. One was this construction team is now prepared for the future of building codes. Number two is because of the better air tightness, they were actually compartmentalizing the units, which resulted in a decrease in sound and odor transmission between units. Just so you know, when we test blower door test units across Ontario and across Canada, you can ask any registered energy advisor this, we find that about 30%, in some cases 40%, of the air coming into the unit when the blower door is running is coming through the common demising walls when it's a 1 hour wood frame stagger stud assembly. They gained the stair space back. They were actually able to reduce some of the heat loss and heat gain loads, which led to a smaller, more compact mechanical selection. The home got quieter. There was better thermal comfort. And again, unit up on unit, this added up to a substantial cost savings. Let's jump to windows. Again, windows, are they friend or foe? One thing I think we do understand is that we are seeing a lot more glass. And we have seen a lot more glass happen in the last several years. Our window to wall ratios are going up from before 2000. We're now seeing window to wall ratios on homes of 17 to 20%. Here's what happens with that. As the window to wall ratios go up, if you were to take an archetype of homes from across Canada and Ontario, what you'll discover is that because we have so much more glass now, that when you get between 15 and 20% window to wall ratio, if you were to put in a good window, let's say a window of 1.2 U value or less, which would be like a tri-pane, it adds an overall thermal effectiveness to the entire envelope that exceeds what would be added if you had added 2 inches of foam to the wall. That's pretty informative, and that's pretty helpful. Again, it's not saying you wouldn't add continuous insulation at some point, but the window opportunity may take place before that. The thing you have to understand about windows too is that there's 2 ways to meet the building code. One is through ER and one is through U value. And folks, I don't think I need to say too much about this, only that even though both these windows are deemed to be efficient all the way up to the territories, the reality is they're 2 different windows. One window is complying on U value, which is here, 1.1. That's the insulative value of the window and its resistance to heat loss and heat gain. The one on the left is ER, energy rating. Energy rating is an old factor that includes the U value. It looks at air leakage of the window, but more importantly, it weights solar heat gain really heavily. What you have here is 2 identical windows as far as Energy Star is concerned, zone 3. However, the window on the right, because it relies on ER, which relies on solar heat gain, has the propensity to raise your cooling load substantially. In some cases, we have seen it raise the cooling loads by a ton to a ton and a half or more on a home. So be careful what you pick. And again, remember, air conditioning is the fastest growing peak load we have out there. If you choose windows with ER, just be careful, because what you might end up with is high solar heat gain, which means you're going to need a bigger furnace fan, which means your ductwork's going to need to be really big, and you're actually going to increase the cost to operate the home for the homeowner because it's going to be electricity. And just to show you the difference between what solar heat gain can do, you can see here, by this example, that if you have a solar heat gain of 0.6, we have seen windows in Ontario of 0.7. That's a 12,000, 1 ton of cooling through a group of windows on south and southwest walls. If you go to just a medium range, it cuts it down almost in half. If you go to a low solar glass, it cuts it down to a third or a quarter. Like, that's a significant difference just by looking at your solar heat gain. Again, I'm not going to continue on that point, but let's just look at the windows when it comes to the exercise of performance. So here was a builder, again, that had access on a townhome project to adopt tri-pane windows. Again, it was a mid-density project. It was in the city of Toronto. There were several hundred units, and they wanted to move from their 1.4 building code window, low E, double argon, to a tri-pane. And they were able to do it because, again, it's a multi-family, little less glazing area. They were able to do it for about $650 to $700 a unit. That was sort of all in. Again, that was a tri-pane single coat of low E. So what we did there is, again, there was no air test involved. The drain water came out. Attic insulation was slightly reduced, which, again, when we looked at the hip roofs and everything else, had very little impact anyways. And we were also able to pull out some of the other measures, let me see what else we did. I think that was it. At the end of the day, what happened was they were able to put tri-pane windows in the home and still save $850 a unit. Now, here's the good news. These windows, which are tri-panes, can handle higher humidity, which means they can keep the relative humidity at 30 to 40 in the winter. They're not going to dry out. The hardwood floor is not going to blow apart. They're not going to have to wipe off the windows on a cold day, and you're going to have a happy camper. The other thing too is it will drastically affect heat loss, heat gain in some scenarios, which in some cases, again, can optimize the size of the equipment that is in the home. And again, the other thing too that these builders have found doing this is that homeowners get tri-pane windows. 3 panes is better than 2. You don't really have to say too much. Sorry, Steph, I've got my PowerPoint has gone on the recovery. Do we have any questions?
Okay, so let me just go to that. So the first question is, and you did touch on this a little bit earlier, but I'll mention it again. It's is SB-12 the Ontario equivalent to section 936 of the National Building Code.
Yeah, no, absolutely. Yes, it is. So 936 for you Ontarians is the energy code for houses and small buildings in the National Building Code of Canada. And I believe that it's right now in the 2015 version, I think, if I have it correct. Is that right, Steph? I think.
Yes. Okay, so another question that just came in is, how do you feel about a four-surface low-E coating?
That's a good question. One of the things I would say on that is just to be careful. If you're in zones 5, which is Toronto, I'm going to have to stop sharing here. Sorry, I'll try to answer the question. Just don't worry about your screen for just a little bit. If you are in zone 5, which would be Toronto, across Canada, a surface 4 low E on a double pane window, you're likely going to be okay. And you're likely not going to have any, I'm going to say, immediate issues. But if you get into the colder climates, what often happens in the colder climates is that the low E coating that is on the inboard face of is on what's called surface 4. What it does is it reflects an additional amount of energy back into the home. And in doing so, you do feel good, a little better anyways than just a typical double. There is a little bit of better increase on U value, but the problem is that the glass itself becomes colder. And that's where you have to be just a little bit careful, because with surface 4 low E, the condensation potential on that glass is much higher. In other words, so if you ever want to find out about what surface potential is on the window, you can ask any manufacturer, and they will have what's called the condensation resistance factor that you can find out. You want to look for something ideally that is around, I'm going to say 0.6 to 0.7. So again, zone 5, wouldn't worry too much about it. But if you're going to be up in Sudbury or North, or you're out in Edmonton or Calgary, it's a little bit of a different concern. Now, if it's on the 6 pane of glass on a tri-pane, that's a different story. Hopefully that was helpful. Is that okay, Steph?
Yes. Another question that just popped in, and it says, doesn't the heat load go up if the solar heat gain coefficient goes down? How does the balance between heating and cooling annual energy look?
That is an awesome question. So thank you. And again, we have so little time today. I mean, anyways, so in our building science courses and when we do optimizations, we absolutely look at that. So you're going to lower solar heat gain because you're worried now more about cooling, because most of the mechanical systems in Ontario today are actually being sized on the cooling load, not the heating load. But so here's what happens. As you lower the solar heat gain, yes, you could start to see your heat loss go up slightly. And this is where you've got to rationalize it. You've got to be careful. We often refer to this as the Goldilocks scenario, not too much, not too little. So to start off, we always say, just to start on your building, start to look at a better U value, try to look at 1.2 or less if you can. And then for solar heat gain, try a mid-range. So if you talk to the glass manufacturers, anything that is above about a 0.4 to 0.45 is considered high solar gain. That's where you really want to be careful, because things get really tough. Anywhere below about a 0.3 is considered to be low solar gain. And then anything in between is mid-range. So we say start with mid-range, and it's sort of a nice balance. Hopefully that's helpful. Anyways. So yeah, we'll leave you with that slide. So windows have become a really big option. Now I want to move on to SB-12 performance when it comes to combos. And the reason this is an important conversation is because as we build more and more multifamily units and the loads start to diminish and our utility rooms get incredibly small and we're jamming equipment in there, it does make a lot of sense to have a single heating source for the domestic hot and for the space heating conditions. However, you all know that under the Ontario Building Code, under prescriptive, if you use combos, you have to use package A4, which is a fairly aggressive envelope. And there's lots of reasons for this based on the modeling when it was done several years ago and all that sort of thing. And what we're finding is when it comes to combos, it is an absolute no-brainer that you would start to bring on board a performance path metric. Again, even without air test, compared to A4, what you're going to find is that not only can the envelope be reduced, and you can look at here that there's, A4 right now requires continuous R5, which is a good thing. But again, in multifamily, sometimes it can be sort of tough, but again, an opportunity to reduce. And here's what the builder did. And per unit with a combo, it was a $950 savings per unit. And that included a notional air tightness testing fee, that included a notional modeling for this project. Now, the thing to keep in mind with this on the note over to your left is that when we talk about removing insulation on the outside, I challenge this notion because sometimes it costs less to pull the insulation off. But those of you that are responsible for pricing right now on contracts and purchasing know darn well that the cost of OSB has gone through the roof. And guess what? It's actually cheaper to move back to a foam plastic or a continuous rigid insulation as long as there's bracing and lateral support in the wall than using OSB. And here's why. The panel goods of OSB and lumber are very much commodity driven and the market reacts very quickly. Whereas with the foam, it doesn't react that quickly. Now, that said, I would caution you to pull the OSB off the wall. It can be done, but you need to know your structure. You need to know the wall. You need to know what your lateral loads and resistance are. Talk to the APA. Corey McCambridge, great guy, can help you with this and can help optimize your home in ways too. So again, an option that you can do, just do it thoughtfully and do it carefully. So again, when you go through the Home 360, the Builder 360 optimization suite, you can look at all different types of options as you move up the curve, and it sort of gives you a path forward. And what we typically find, I want to draw your attention to the right side of the screen there, is that builders and our clients, that when we get them into performance or performance with air test, it's like a first step towards this better built home and product. And what they often find is that, guess what? Energy Star, in particular on multifamilies, in some cases is cheaper than A1 or cheaper than A4 when it comes to a MERB. So do your homework, sharpen your pencil, have the conversations, sit down and hash it apart, and you'll come up with some pretty compelling figures at the end of the day. And then the other thing too is we would never encourage anybody to move to net zero right away, but just understand that you're closer than you think. So make it part of that 1, 5, 10-year plan. Let's talk about application documents. One of the things that we have found is that you need to have clear building permit application documents. It's incumbent on the Building Knowledge Canada as a registered evaluator to take on the responsibility to make sure that we provide proper files and modeling and professionalism and knowledge in the report to the building official. The plans examiners and the building inspectors have a lot on their plate. We love to have conversations with them. Angela and our team spend a lot of time talking to these folks because there are a lot of questions. It is complex, and again, we're here to help. And that's the thing we would encourage is clear reports. And also, as a builder or industry member, look for recognized energy professionals, professional third-party validation, and correct tools and software. Let's look at each of these individually. When we talk about clear permit applications, we need robust reports that can go along with the unit or with the block or with the project. Also, the energy advisor needs to take responsibility for signing the performance EEDS form, not as the BCIN. The BCIN still has to take responsibility as a qualified designer, but you'll see here that under this area here, performance or Energy Star or what have you on performance, this is where the qualified performance energy modeling professional puts his name, company, and the evaluator rater license. What this is referring to is that is the qualified registered number that they as an evaluator have with the government of Canada. What this is doing is this is taking risk away from from you as the builder, and it's taking risk away from you as the municipality that's accepting the permit. How do we apply when we start to have homes that are not just single detached? One-off, one report, proposed versus reference, explanation of what's being targeted, all the details and the specs figured out. However, what happens when we get to multifamily? When there's multiple units based on iterations of plans? What happens when we get to blocks? And that's where we would say you need to understand what the region's goals are, what's their experience with applications under performance. And that's something that we as building knowledge take on so that we can have a conversation that at the end of the day, we can provide them what they need so that they feel comfortable, but we can also do it in a way that's efficient, that also looks at reducing costs or optimizing the modeling process. The other part aside from the process is the individuals who do it. And what do you look for when we start to look at validation professionals? A couple of things to look for is the Natural Resources Canada, the Registered Energy Advisors, talks about who they are, what their accreditation is, what their test requirements are, their exams, the retesting every 3 years, all the professional conduct. The other place to go is the Canadian Association of Consulting Energy Advisors. There's the website all across Canada, all across Ontario, 100+ members strong and growing rapidly, are registered energy advisors and professionals who can do this, and they abide by professional conduct. And so these are the individuals that you're going to want to deal with. When it comes to software, lots of discussion these days about the software. I'm just going to draw your attention back to what is in the SB-12. Again, in the SB-12, under performance, in the appendix, it talks about the parameters that have to be set in the model. And when it talks about the assumed operating conditions, and those operating conditions are directly out of the EnerGuide rating system. You can apply those conditions onto their software as long as whoever's doing the modeling is accredited, as long as they're have a professional designation and you have confidence in them, but it is based on the EnerGuide system. Currently in the SB-12, when it references the appropriate modeling programs, it talks about HOT 2000, it talks about any ResNet software, which could be things like RemRay, Ecotrope. There's several others that are available. But again, any of these can be used as long as they use the reference conditions set in the building code. The other thing too, I bring to your attention, we have been challenged, and rightfully so, that depending on some of the software that you use, some of the software uses US-based algorithms, whereas software such as HOT 2000 and others use Canadian-based algorithms. So you may want to look at using software that references things like the Alberta infiltration methodology, which has been around for years. It's actually much more robust than what is used in some of the US softwares. It's built around the same standards that the CSAF 280 is, the Enercan reference files, things like that. So again, not to say that other softwares can't be used, but if you are concerned about risk, these are things that you do need to be made aware of. We would say as an energy modeling team, we've used them all. They're all good. There's very little difference between them as the end results. I'm sure there's always going to be little notional differences that might benefit one technology or another. But at the end of the day, ours all modeling at the end of the day is not going to be perfect. Some is going to be helpful. Just make sure the professionals who are doing it are transparent, they're clear, they're helpful, and can work with the clients. I do want to focus in a little bit too, because when it comes to meeting the building code with performance, in almost every case, you are going to be doing better than what's at the minimum code. And so we've developed just a little bit of a package that can help with some of our builders that, understanding that your team's smart, you're using building science, your homeowners know you care. The reality is you're using Canadian building science and you can prove it. So here's just a couple tools, a home profile report that can be used if you want with a homeowner. There's a customer or a home manual that speaks to things like ventilation and operating the home, a high performance home, and then just a small little recognition that can go on the home to show again, if there's an air test that's required to meet code, it shows those items on there as well. The other thing too to understand is that our Home 360 supports and integrates directly with these recognized third-party programs. So depending on what you want to achieve at the end of the day, if you decide to look at some of these volunteer programs, this integrates very nicely into the Home 360. So we would say too, when you're working with your trade partners, number one, make sure you have a 1, 5, 10-year plan. I'm just showing a picture here of some of our typical builder analysis that we provide with our clients. We like to meet once a year or so. We give them a report on all their sites, how it's performing. We like to meet with their site team, and it gives them some feedback on areas they can improve, but more importantly, it gives them feedback on where they're doing really, really well. And at the end of the day, it's all about improving the bottom line. Couple things you folks need to keep on your horizon, things that will affect your decisions going forward. We know that you have this proposed harmonization of codes that we might be looking at. Many people are asking, what is the notional date? From the conversation that was had at the Ontario Home Builders, I think last Friday at the technical meeting, anyone should join that has the ability. Please join. It's a great group of folks. The ministry said right now, it seems that once the new tiered energy code is published, which will likely be the end of 2021, that the idea is to have around 2 years or so before it would actually be brought into the reg. So we're looking at 2024 or so. That said, folks, it's notional. The Ontario home builders need to review it. The industry needs to review it. There's things that we may like, there's things that we won't like, and there are things that we do have the ability to change as a province in effect. Partner funding. Those of you that are developing low income or affordable housing projects, there is significant amounts of funds that are available based on the efficiency of projects. And we are very busy right now helping developers and builders meet the CMHC requirements. And there's a lot of help available here. The federal government, you all saw the release this last week of their efficiency plans. We know that we're looking at support for 1 million EnerGuide rated homes to come in over the next few years. Here's the thing I want you to remember. Your biggest competitor as a home builder is who? It's your own homes or the existing homes around you. When we look at 1 million homes having a gigajoule rating on them, the one thing you want in order to show that you are better than the existing is for them to understand what the fuel economy is on your home. So there will be a benefit. Once we have 1 million of these homes in, that's a fairly big impact. The other thing too is there is some financial programs coming in eventually for deep energy retrofits. And the other thing too is the Canadian home builders are working feverishly right now with the Canadian Appraisal Institute to start to look at what would efficient appraisals mean, even for new homes based around the efficiency of the home. And this has been done in the US with a lot of success. So something to keep your eye on. Again, if you want to understand what your path ahead looks like, here's your cheat sheet. If you're starting to look at 1, 5, 10 years, the very first step towards the next 10 years is simply getting used to performance. And at the same time, you can reduce the cost associated with the construction of the home. After that, look at air tightness, then move to windows, then move to walls, and so on and so forth. So that's your first step. Get involved, move to continuous improvement, understand that you can build a better home for less cost. I will tell you, as a former builder, that I actually don't know that I've ever seen a time like this when there's been such a compelling opportunity to build a better product for less cost. Rarely are we able to say that in this industry. Understand how close you are to things like Energy Star and net zero, thoughtfully understand where net zero is coming and when it's coming. Make sure that you're reinforcing your brand. And again, remember, the building science, your team is smart, your homeowners know you care, you can use Canadian world-class building science and you can prove it. So give us a call. Steph, there's some information there. We'd love to chat. Steph, I'm going to hand it over to you.
Okay, we do have a few questions. Did you want to, I guess we'll do that afterwards, right?
Sure, absolutely.
There we go. Sorry, I was having a bit of technical difficulties. My video didn't want to come on there. All right. Okay. So what we're going to do is just give you a little introduction of some upcoming webinars. So Enbridge is sponsoring a webinar series, an advanced building science webinar series that occurs every month from now till the end of next year, end of 2021. So the next session that's coming up is December the 10th, and Gord Cook, along with Mark Rosen, will be speaking to the National Tiered Energy Code. So be sure to register for that. If you haven't already seen it, I will send a link so that you can register for that. And we have a very exciting thing that's coming up, and I think you're going to move to the next slide.
Sorry about that stuff. There you go.
No problem. So the Builder 360 Unplugged. So this is brand new, and so we will be launching this next year. But we're very excited to have an avenue for builders to talk to builders, basically. And so this is them sharing their stories from the front line. And so the first sessions that we're going to be having in February are on the same topics that we're talking about today, but digging in deeper and hearing it from different builders' perspectives. So Andy, I don't know if you wanted to add more to that.
Yeah, and we called it Unplugged for a reason, folks. We want unadulterated, we want honest feedback. So those of you that attend, get ready to have some of your ears burn. We're going to have some folks, you'll have some of the Doug Terrys of the world, you'll have some folks from some of the larger production builders, you'll have some custom, talk about their experience with performance, how they're doing it, why they're doing it, where they're finding advantages with selling homes, whether they're in a program or not, it doesn't matter. But really what it's about building science. And it's going to be pretty cool.
Exactly. And from the builder's perspective, you know, they know it, they feel the pain. And so this is going to be fantastic. So did you want to tackle some of these questions?
Yeah, actually, I saw a couple of good ones come up there today.
All right. So here's two that are kind of connected together, I guess you could say. So Jason was asking, we're looking at removing the OSB sheathing and only installing 2 inches of rigid. And he was looking for who the contact and company you'd mentioned for the lateral bracing. And I believe that may have been the APA. Was that the one you were referring to?
Yeah, reach out to the professionals. Corey McCambridge is one of the Canadian designers representatives for the APA. And again, we can get you in contact with them, and they understand the structural requirements of the building code better than anybody. They can actually work with your designers, your architects, and your lumber suppliers to optimize and to bring into play what's needed there. But that's good to hear. 2 inches is pretty good. I'm guessing that's about a 7 to R10. That's a really nice wall, keeps the wall warm and dry. So good move.
And so Liz had asked, are you aware of the upcoming changes to lateral load requirements in the code, which will likely require OSB sheathing in many parts of Ontario?
Yes, thank you, Liz. Yes, and that's again why we want them to go talk to Corey McCambridge. So Corey works along with folks at APA. Robert Jonkman, Canadian Wood Council would be another one to talk to. And again, a lot of these loads, thanks Liz, are coming down the chute at the National Building Code level, and they're also coming into Ontario. So thank you, Liz, for that. And again, a lot of this has to do with, from my understanding, with some of the updated weather codes, weather files, which will affect fastening and other items on the home. So.
And Zoran had asked, what is Home 360? So maybe we just want to cover that again.
Yeah, so the Home 360 basically, as building knowledge, we have a lot of clients that like to, do a little better than what is the code. They like to use the building science. So what we've developed is just a little way to acknowledge that, something that you can prove to your consumers. And I'll be really honest, your own team, something they can take pride in, that this is a home built with science. So it's a little bit of a marketing support that we can support you with.
A few people had asked if they're getting a copy of the slides, and yes, you will get a copy of the recording. There's a link for the recording. It just takes a couple of hours for it to process. So later on today, you'll get an email with that along with a PDF of the slides. Let's see here. What is the R5 CI mean in the A4 combo slide?
So the R5, sorry about that. Sometimes we use these acronyms and think that we all sort of know. So the CI stands for continuous insulation. So CI is basically a little acronym that the 5 would mean there's a continuous layer, thermal break of continuous insulation there.
So Susan has asked here, looking at retrofits, if the homeowner is replacing windows, would you definitely recommend triple pane with low or mid solar heat gain coefficient and a low U value for southeast, south, and southwest windows, or The same recommendation for all directions.
If they have the opportunity, optimize them for the sides. If cost is a concern, then optimize them per side of the home. So obviously on the north and the other faces where they're not facing the sun, you really want to take advantage of the U value, reducing the heat loss. I mean, the inside pane of a tri-pane window is so warm that even at -20 to -25, you're going to be able to sit close to it and not know you're cold. That's the difference between a good 1.2 U value or less and just a good double pane. For the other sides, I still would suggest a tri-pane, but there you might want to start to optimize for solar heat gain depending on the orientation. Now, we're finding that you can do that with overhangs on the design of the home, but again, it's a retrofit, so you might be limited. But that's something that a good window manufacturer can help you do. They can help you optimize. There is a tool, we often use it, it is free, that you can do this on. It's called the Thermal Comfort Calculator with Cardinal Glass. And homeowners or you folks can go on and you can actually put windows with different glazings and find out the effect it's going to have on you.
Another question that came in, thoughts on wood fiber board sheathing?
Wood fiber board sheathing, been around for a long time. Yes, it's a good product. It's often put in for primarily for structural resistance. It's got a little more R value than at least the ones I've seen, a little more R value than just your 7/16 OSB. Good product. Again, like any other material, just make sure it's installed right. And yeah, from a building science perspective, I would say if you really want to go from good, better to absolute best to make sure that that wood fiber stays warm, put some insulation on the outside. You're going to have to do it eventually to get to zero. Consider doing it. But yeah, good product.
So kind of to the comment that you made regarding the renovations, could we max out solar heat gain coefficient of windows with optimized sizing and positioning of overhangs, sort of the passive approach, passive heating approach?
You can, but let me just warn you about that. Our experience with doing that, we learned this in the 70s. Our folks remember in the 70s, well, maybe some of you don't, we build these homes, we put lots of glass and we put it towards the south. And then we build this big stone fireplace in the middle of the home that was going to soak in all the heat and re-radiate it after the sun went down. And we'd have overhangs that were done at the right angle so that the high summer sun couldn't get in, but the low winter sun could. That's okay. The problem with those homes is they were often uncomfortable because the sun doesn't always shine, so that you actually need a better glass. The other part is our homes are different now. Our main comfort issue in homes these days isn't being cold, it's being too hot. It's cooling. And what we're finding with some passive designs that don't make use of good solar heat gain selection or optimizing and just rely on overhangs is you may still run the possibility of overheating even in cold periods. So just be a little careful. And again, when you have lots of design flexibility, it might be more appropriate. But if you're designing a subdivision and have some restrictions, I'd be very cautious.
So we are a couple of minutes after 2, and so I just want to remind everybody this is being recorded. So Andy, we probably could tackle a few more questions, but it is being recorded. So if anybody needs to hop off, they will get the link after. Are you okay with doing a few more questions?
Yeah, absolutely.
Excellent. Okay. So here's one. Does polyiso insulation perform poorly at cold temperatures? And if so, should it be used instead, or should be used instead if it's significant? Quite clear on the last part of that. Basically, yeah, how does it perform in cold temperatures?
How does it perform? So here's the thing to understand. Yes, we know that polyiso is a closed cell foam. Typically, it's put in a board form. Typically, it has a foil face on it. We know that when it gets really cold out, like let's say, below 0 degrees C, that the R value does diminish. And I think I've seen testing that it will go down to, from R6, it might go down to R4. So if you really are concerned, then yeah, use something else. Is it a game changer? It depends. I don't know. You got to be reasonable. Now, let's talk about the science of why this happens. Is because when the temperature drops, the blowing agent that is inside the cell condenses and clings to the wall of the cell structure, which increases the thermal conductivity. When it starts to warm up a little bit, it goes back into its vapor form, if you will, and the R value goes back up. So again, um, yes, it's not as good all around performance as say an XPS or maybe an EPS or something else. Um, but again, I mean, rationalize its use based on what your needs are. I'm going to answer that cautiously.
Okay. So this is a question on HRVs. And so the question is, are there any emerging efficiency improvements on HRVs, or are the off-the-shelf brands basically maxed out on efficiency improvements?
Sort of depends. We are seeing a lot of advancements come in with HRVs and ERVs. We've got units now that are upward 80% plus without any issue. We are seeing a lot more use of ERVs for a lot of different reasons. We're seeing controls are really the big deal now. Controls that, you know, the homeowner doesn't have to play around with them. These units are smart enough to take the outdoor conditions, the indoor conditions, and balance the relative humidity a little bit and look at temperature and optimize its runtime. All you have to do is hit a smart button. I will say that probably most of the advancement that we're seeing that's making a big difference as far as the efficiency is less about its heat recovery ability and more about the efficacy of the fans. So going to DC brushless type fans has a huge impact on the efficiency of the homes. But yeah, good. That's a good question.
Okay, so this one is, what continuous insulation R value is equivalent to 2x6 16 on center R20?
Oh boy, what continuous insulation value? Say that again.
What continuous insulation R value is equivalent to, the way I'm reading this, an R20 bat in a 2x6 16 on center wall?
Okay, so without any cladding on the outside, because remember your effective R value, you have to take the airspace on the inside into account. You got to take the drywall. You then have to take the type of cladding, whether it's brick, whether it's stone, whether it's vinyl siding, whether it's wood, whether there's an airspace. A lot of things have to come into there. So we need to know a lot more. But if it's just the wall alone, R20 bat, 2x6, 16-inch on center, 3 stud corners, traditional framing with vinyl siding on the house, you probably only have an effective R value of somewhere between 14 and 15, and it's probably got a couple decimal points in there too. So yeah, when you tell a homeowner that you're putting in an R20 bat, it's actually a 14.5 or a 15.7. And so yeah.
And the last question is with regards to the cost of performance evaluations. And so the individual is wanting to know how much do performance evaluations cost, generally speaking?
I'm going to give you the politically correct answer and say it depends. And the reason is, like anything else in the industry, is it one? Is it two? Is it multiples? And that's why we say we like to look at the site as a whole. And most energy professionals will want to quote based on the work. But notionally, for budgetary purposes, for those of you that are scratching in numbers just to keep track, you know, an air test, you're going to run anywhere between $200 and $350, some more, some less. Just remember, you're going to get some more or better information out of some EAs than others. For modeling, put a placeholder in there of about 300. It could be substantially less depending on the number of units and the size of the site, or it could be more if it's a custom. We've done some large customs that are in excess of 15,000 square feet. They're large custom homes. To do a performance evaluation for homes like that is then based on a square footage. So it's a little bit different.
Well, let me just check the chat. All the Q&A.
I saw one from Richard Lay on there, and I'm so glad to see Richard on there. I just thought it was a really good question about HRVs and the additional saving to your window upgrade scenario. Downgrading the ERV from 75 or 81 to 65 will be a cost savings, and I didn't show any change. Thank you, Richard. You're absolutely correct. And the other thing too, Richard, about that, and Angela's actually done that, is you can downgrade the size of the HRV and the ERV, which also means the unit potentially can be smaller so that it can actually fit and go into these multifamily units better. And that's awesome. someone's going to ask the question, maybe you haven't, but can you actually performance model out HRVs and ERVs? And the answer is you can. You can do a performance path and you can pull them out. We would never encourage it. Have we done it once or twice? But here's the beauty. If you cross your T's, dot your I's, work through the optimization, you can optimize the cost of an ERV and HRV and keep it in. Folks, in homes today, air barriers inspected, homeowners' lifestyles are what they are. We're in a time of COVID, we're at our homes. It would be a shame that we wouldn't put mechanical ventilation with heat recovery. I mean, I really struggle with that. It's like handing over a bill of goods that you know isn't really going to work, but hey, anyways, that's my personal opinion.
Well, I will concur with that. As someone who's lived in a home that didn't have any HRV or ERV, and now and that does have, there is a significant air quality and smell difference between. And I think at the end of the day, the consumers will certainly have an opinion on that. So one other just quick question that someone had asked was, with regards to performance modeling in the report, they were just asking if the reports can be simplified so that there's not so much computer data, and just what sort of flexibility there is in the reporting part.
There can be a lot of flexibility on our part as the EA. We love to work with the municipality to find out what they need. And some jurisdictions want a lot of information. Some jurisdictions actually have staff that are dedicated to reviewing this. Others, they just need to know the numbers are what they are, and they just need it validated by a professional like ourselves. So we'll work with them to simplify it as much as they feel it can be simplified. So.
All right. So let's see here. One last thing that just came in, and this sounds like it's a made for TV question. T-studs and zip type R, is the hype real? I think that's a good one to end on.
I think it's going to be interesting. I mean, those are the types of things that as we see the cost of wood go up, we're going to see more of that. We actually, just on that note, and then we need to wrap it up here. I was talking to a large manufacturer this last week. You're going to hear about them soon. On the modular side, they're moving into Ontario. They're looking at the potential that all of the modularization of units can actually be done with cutoffs. It's all lean manufacturing, all done with cutoffs. You're going to see some really unique stuff happen. So, all right.
Well, I think we actually managed to get through all the questions too. So that's perfect.
Very good. Thank you, folks, for being patient. Hopefully it was helpful. Get a hold of us. We'd love to help. And if we don't talk to many of you before the holidays, all the best to keep healthy and happy and hopeful. So
absolutely. And so just a reminder, when we end this, a little SurveyMonkey link will pop up, so please fill that in. And later on today, I will send out an email either today or tomorrow, depending how long it takes for the audio and video to process. But that will have resources in there. So you'll get the PowerPoint, you'll also get the video audio link. And then also Andy had mentioned the APA and Cardinal Glass, so I'll throw those in there as well. Okay, so hope you guys have a great day, and hopefully we will see you on December 10th for our next session. Thank you.
Thank you.
Bye.